So standard position, vertex at the origin, initial side of the angle on the positive x-axis. We want to draw 0 degrees in standard position. Vertex at the origin, initial side on the positive x-axis. 0 degrees, you're not going anywhere from that point. You stay at the same level. No rotation. Okay? That's 0 degrees in standard position. What you're going to learn today is how to find trig function values for angles that lie on axes, like x or y axis. Okay? Any questions on 0 degrees? Okay. Show 1. 90 degrees. Can you guide me through drawing that? First quadrant? It's actually not in a quadrant because it lies on an axis. Does that make sense? Where's the vertex? 0, 0. And where's the terminal side going to be? The y-axis. Yep, the positive y-axis. And let's put the arc here. That's 90 degrees in standard position. Okay. Gabe. 180 degrees. Guide me through graphing that.
Well, the red thing is in the same place.
Say again?
The red line is in the same place.
Correct. The initial side, which
Always there.
I've used the color red for, same place, good.
And the green line is going to be a reflection.
Yes,
Wax.
very good. Green line is going to be a reflection across the y-axis. Technically, it's a ray. Let's draw the arc. Okay. Good. And Nakia, hopefully this helped. Can you describe to me how to draw 270 degrees? Mm-hmm. The red's in the same spot. Green's going down. Very good. Do we have to say timber, Nakia? Okay. All right. I'll say it. Timber. No Kesha fans? You know my tricks. Dominique, guide me through 360, please. Yep. Very good. So we've made a complete rotation. Amber, 360 is coterminal with 360 degrees is coterminal with, meaning has the same terminal side, or the terminal sides overlap.
Oh, on the initial side?
So give me another degree measure.
0 degrees?
Yeah. Okay. Do you see how the green is in the same spot?
Yeah.
Okay. That's significant. For example, the sine of 360 degrees, as we'll find out, is the same thing as the sine of 0 degrees. There's reasons for everything that you learn. You just may not know what they are. Okay. Any questions on the warm-up? We still have more to do, though. I asked you to find coordinates of points on their terminal sides, so let's do that now. Jessica, could you give me coordinates of a point on the terminal side for 0 degrees? 0, 1, as per the Cartesian convention, is going to be here, yeah?
Oh, sorry.
So try again. 1, 0. I like that answer. And Nikki S., a point on the terminal side for 90 degrees? 0, 1. Good. Just 0, comma anything. Dan, 180. Negative 1, 0. Good. And Jessica again, 270. Say again. One more time. Thank you. And Terry, 360. There you go. 1, 0. Okay. Any questions on that? We're going to use the coordinates to find the trig function values. For example, tangent is y over x. Okay. All right. Val, can you tell me the definition of sine in terms of x, y, and r?
It is opposite of one.
Okay, so let's do this first. In this triangle here, Val, if this is our angle of interest, what's this side? Like, what would you normally like call this side? Like in general. Yeah. And this? And this? Uh-huh. Do you remember when you did the drawing, Val?
Yeah.
So the opposite side was what? X, Y, or R?
That's all.
Yep. And the adjacent?
Is X.
And the hypotenuse?
Is R.
Good. So try again. What's sine in terms of X, Y, and R?
Y and R.
Good. Chowan, cosine definition? That's true. In terms of X, Y, and R, though? Very good. Nikki B, tangent definition? In terms of X, Y, and R?
Opposite over adjacent.
That's true. In terms of, yeah.
It would be Y over X.
Very good. Brett, cosecant?
It's hypotenuse over opposite,
Excellent.
so it's r over y.
Very well done. Val, secant?
R over X.
Excellent. Amber, cotan?
X over R.
Try one more time.
Oh, R over X, sorry.
Try again.
Wait, what?
So tell me what you know about cotangent.
Oh, X over Y.
There you go. Okay. Any questions on the definitions? So I would know the definitions in terms of X, Y, and R to succeed in this area. Okay, so we're going to find the sine of 0 degrees. Well, take a look at what we did here. We said a point on the terminal side is 1, 0. That's going to matter. X and Y. Question is, what is R?
It's not even a triangle, it's a line.
Isn't it the two sides, it's like the Pythagorean theorem?
Very good. Yeah, very good.
A squared plus B squared
Yeah.
plus C squared, or R in this case.
So from the Pythagorean theorem, you get this. Okay, because it's r squared equals x squared plus y squared. Okay? R is also the distance from the origin to the point. That might help you as well. So our x here is 1, and our y is 0. Hopefully you can see how this just reduces to the square root of 1, which is 1. Okay, so now we have a value for r. So the sine of 0 degrees, we have a definition in terms of x, y, and r. It's y over r. What's my y value? 0. And my r? 1. That reduces to? Very good. Ladies and gentlemen, you just found the sine of 0 degrees. Nice job. Okay, thank you for speaking up. You need to know the definition. It's y over r. Then you need to find a point on the terminal side. We said 1, 0. Good so far? The 1 is your x. The 0 is the y. Now you just need r. R is the hypotenuse. It's also the radius. And it's also the distance from the origin to the point. You can find it with Pythagorean theorem. But actually, this is a really simple one here, because one of your sides is 0. So hopefully it's obvious to you that this distance is 1. There you go. You have your y, you have your r. 0 divided by 1 is 0. So the sine of 0 degrees is 0. And you can prove that with the calculator. And plug in sine of 0, better give you 0.
Wait, why did you do 0 divided by 1? Like, I know where the 1 came from, but where did the 0 come from?
0 is the y coordinate of...
Oh, okay, I got it.
Okay. Any other questions? Now let's find the rest. Hopefully it's much easier for you now. Dan, cosine of 0. What do you think it is? You think it's 0. Let's check it out. We know cosine is x over r, right?
It's 1.
Okay, I like that. The x is 1, the r is 1. Cosine of 0 degrees is 1. Yes?
Is R going to be 1 for all of them?
The question is r going to be 1 for all of them? I would always use 1 for r because I think it makes it the simplest. Okay.
So you should always use 1 for
I would.
R. So with the
You do whatever you want.
tangent is undefined.
Oh, I like how you moved ahead. Okay, so we're going to get some undefines. Let's look at tan. Jessica, what do you think tangent of 0 degrees is? 0. Very good. Okay. Tangent is y over x. 0 divided by 1 is 0. Dominique, what do you think cosecant is? Excellent. Cosecant is undefined. If you want, you can use the null set symbol. I'm okay with that. Bless you. You cannot divide by 0. Bless you. As a former math teacher here said, you cannot sit on 0. But 0 can sit on you.
Oh my god, where did he go?
Secant. Val, what do you think secant of 0 degrees is?
1.
Very good. 1. And Nikki B, cotan?
X, Y,
Mm-hmm.
1. No, 0. Undefined. Oh, because 0 is at the bottom? Okay, so
Yep. Also, please note, you can flip the first 3 to get the last 3. Cosecant is the reciprocal of sine. 1 over 0 is undefined. Secant is the reciprocal of cosine. 1 over 1 is 1. Cotangent is the reciprocal of tangent. 1 over 0 is undefined. Okay? Any questions on the 0 degree row? Great. 90. Okay, so the reason I put this coordinate plane here was so that you have a simple diagram that you can use for your reference. And it will look as follows. It will consist of 4 points, and then the coordinates. The simplest ones, I think, are 1, 0, 0, 1, -1, 0, and 0, -1. And hopefully you know by now that this is 0 degrees, this is 90 degrees, 180, 270. So I'll show you how I use this. I want to find the sine of 90 degrees. Sine is y over r. I go to 90 degrees. The y coordinate is 1. And r is going to be 1 for this diagram. So you can make a note that r will be 1. Repeat which? The whole thing?
Not the whole thing, just the
Are you having questions about why r is 1?
I mean, I guess. I don't know. I don't know.
Try again. What's it? What?
I
Is
don't
R
know.
always going to be 1?
Yeah, like my question is R always going to be 1 for like all of the degrees?
So Dominique asked me that, and I'll repeat what I said to her. It's not necessarily always 1. It's the simplest one, though. And it corresponds with using these coordinates. If I made this point 2, 0, Val, what would r be?
Oh no, not 2. The radical.
It would be 2. Remember, r is the distance from the origin to the point. Okay? So to answer your question, r is not always 1. However, I think it's the simplest one to use. Okay? It's always the distance from the origin to the point. Jen, tell me again what I got for sine of 90 degrees. So 90 degrees is up here. Sine is y over r, right? Okay. Okay. I will just tell you that it has helped me in some contexts, like finding the sine of 90 degrees. I find it easier to work with than opposite and hypotenuse. Okay. Y is 1. R is 1. What's 1 over 1? 1. So the sine of 90 degrees is 1. Nikki S., what do you think the cosine of 90 degrees is? 0. Very good. X is 0. R is 1. 0 over 1 is 0. Chowan, tangent of 90 degrees? Tangent of 90 degrees is not 1. Tan is y over x. So 1 divided by 0, Chowan, is what? Undefined. Okay. You can try that with your calculator. As long as your calculator is in degree mode, you can do tan of 90. It should say error. Brett, cosecant, 90 degrees. 1. Very good. Gabe, secant, 90 degrees.
That'd be undefined.
Very good. UND. Sue, cotangent, 90 degrees. It is 0. Okay. Please speak up if you have a question. Okay. Now 180. You're using these points here. R is still 1. R is positive, always. Okay? So I'm glad that you said that. R is always positive.
Wait, why?
Why?
Diagram.
Wait in the negative.
Pythagorean theorem. Brah.
Just like the hypotenuse.
R squared equals x squared plus y squared, right?
Yeah.
R is therefore the square root of x squared plus y squared. Agree?
Sure.
If x is negative, when you square it,
Positive.
yeah, as will
When you're
y.
in the second quadrant and it's distancing.
I get what you're saying, but using this definition, R is always going to be positive. I think what's happening for you is you're using the suggestion I gave when trying to find trig function values for non-acute angles in quadrants other than 1. Like, for example, if you wanted to find the sine of 120 degrees, no, let's do something different. Let's do cosine of 120 degrees. Reference angle is 60, right? So you're 60 away from the x-axis. Drop an altitude, like it's hot or not, your choice. Then label it. You can label it -1 here, positive root 3 here, but this is always going to be positive.
Why is -1 the bottom?
I only told you all this because I find it's helpful. So if you wanted to find the cosine of 120, you can then just use this diagram, not worry about Santa Claus.
Pretty worried.
Okay? Cosine, if you know it's adjacent over hypotenuse, bam, there you go, -1/2. But because I put a negative sign here, it doesn't mean that a side length is negative.
Just to show you that.
It's just a helpful thing. Okay, 180 degrees. Jen, sine of 180.
Okay.
You got this.
I don't like this y over r thing.
That's fine.
Okay, so we have, I can't even see it from here actually.
Okay.
Right, we have the
Sine, right?
Yes.
Which is opposite for
It is.
okay. So we have y over r.
Yes.
And the y, I think
It's 0.
Okay. But yeah, well, so just leave it 0. Yeah.
Very good.
Go with this one.
So Jen, I'll offer you something
Yeah.
since you like to use opposite, adjacent, and hypotenuse. It may not work for others, but we'll give it a try for you. Okay, what's going on at 180 degrees is you have a flat triangle. I can't really draw a triangle, right, if it's completely flat.
Yeah.
So this isn't exactly accurate, but I'm doing it just to illustrate a point. This is the opposite side here, this little height. This is adjacent, this is hypotenuse. What's still important, though, is that you know that the opposite side is what?
Yeah.
Yeah, it has no height. It's flat.
Oh, yeah. Understood.
Therefore, sine is going to be 0. Because you have 0 over whatever. Okay. Next, random person. Julia, cosine 180. -1. Good. Hopefully you're getting this. X over r, the x coordinate is -1. R is always going to be 1 using this set of points. So -1 divided by 1 is -1. Celine, tangent
Of 180.
of 180.
0.
0. Good.
Why is it negative?
I'll try again. So you need to know the definition of cosine. It's x over r.
Okay.
You go to 180. You find the coordinates of a point on the terminal side for 180 degrees. I think the simplest ones to use are -1 and 0. -1 is the x, 0 is the y. If those are your choices, then r is going to be 1. So then you just divide. Yeah, I'm with you. You just divide -1, that's the x, by 1, that's the r. And -1 divided by 1 is -1. R is the hypotenuse.
Why did I get negative 1
For cosine, it is -1.
No, for R.
R is always positive.
Oh, so it's never negative?
It's never negative.
That's why.
Yep. Allie, feel free to join somebody. Yeah. You're not being shunned. This isn't like the 1950s. Okay. Where we put a dunce cap on you. Yes. Nakia. Okay, Nakia, cosecant of 180. Very good. It is not a number. Dominique, secant 180? -1. Good. Jessica, cotan 180? Try again. It's the reciprocal of 0. The reciprocal of 0 is actually not a number. You cannot sit on 0, but 0 can sit on you. Okay? All right, we're making progress here. Julia, sine 270? -1. I'm really glad that you're noticing patterns. I expect it to be the opposite of 90. But let's see. Nick, cosine 270? Cosine is actually never undefined because r is not going to be 0. So if you go to 270, no. It's x over r. So 0 over 1 is 0. Jessica, tangent 270? Undefined. Sue, cosecant 270? It is not. So cosecant is the reciprocal of sine. So what's 1 over -1, Sue? -1. Amber, secant 270? Undefined. Yep, it's the reciprocal of cosine, and the reciprocal of 0 is undefined. Nikki B, cotan 270? 0. Any questions on the 270 row? Okay, Nick, sine 360? 0. Julia, cosine 360? 1. Chowan, tangent 360? 0. Nikki B, cosecant 360?
0.
It's undefined.
Oh, okay.
And Allie, do you want to try secant 360?
Can you go up so I can see because I didn't get the power 1 over just 1. Is the answer 1?
Very good. Val, cotan 360? Undefined. Notice that the 360 row is the same as 0. Very good. Okay. Any questions on that table? I encourage you, rather than memorize, to understand why the values are what they are. Okay? Okay. The section 1-3 practice. We're first asked to sketch an angle theta in standard position such that theta has the smallest positive measure and the given point is on the terminal side of theta. So our given point is 4, -2. That's going to be on the terminal side of the angle. My random helper is Terry. So Terry, tell me how to sketch number 1.
You would
4 spaces to the right,
yeah.
2
2 spaces down.
spaces down. Good. And then what?
Draw an arrow to the point
Good. From?
from this
We call it the origin.
the origin.
Okay. I need some more, Terry.
You
So angles have 2 rays to them. Yep. Initial side on the positive x-axis. And I need one more piece, Terry. The arc. So is it going to be here? It's not. It's standard position. So it starts from the positive x-axis and you go counterclockwise from there.
Can you draw a negative position?
Yeah, you can. And it would be this then.
Yeah, but then how do you know that that problem doesn't want you to draw?
By using your ability to read English.
Oh, okay.
Okay? Any questions on 1 there?